Hello everyone. Today we are going to build this mini breakdown game built using p5.js. First of all, we will start with overviewing what we are going to focus for the end goal. So basically, when we click on this particular refresh, the game will start. The lower, when it will strike the lower plate, it will bounce up, and when it will strike on the upper side, then the particular bricks on which it will strike, that will are going to break down. This is a mini game which we are going to build here. It will going to be use some physics logic, some math logic, and all. That is our end goal which we are going to build here. So we are going to start making all of the thing. Firstly, this is the starter code which p5.editor gave us. Let's run it. After running, we come to know that it is a canvas. So we have two properties here. We have setup function and we have a draw function. In the setup function, we create all the setups. We create the canvas and all. And in the draw function, we are going to define the property which are we are going to use. That in that particular we are going to use. We are going to use auto refresh. If any change will occur here, then that will be auto reflected on the canvas here. So as we can see that the canvas size is small, we need to increase the width. So we are going to increase the width. As you can see, width got increased, and I guess height will be good. If we want to increase the height, we can increase 500. That will be good enough. 400 will be good, I guess. And we need to have a background color dark so that things will be visible in a better manner. So I'm going to use 30 here. You can use the it make all of the background dark. Basically, create canvas function created whole of the canvas, and we have draw function drawn the canvas color to dark. That we have done till now, and our end goal is to make the mini uh, mini paddle breaker game. So for that we need a paddle. So we are going to start with creating the paddle. So if we think of a paddle, what we come up with? Something like rectangular shape. We are going to initialize the variable as paddle. It is variable. Basically, it will be an object we are going to use to we give it some properties. Like paddle will be going to have some height, it's going to have some width, and also we need to define one particular height which we are going to display it. So we need to give all these particular component. By default, values will be height and is for the y-axis height, and for the x-axis it will be 0. By default, we need to change the setups. So we have gone into the setup, we have created the canvas. Now we need to initialize and use this particular variable. We have paddle, so we have used that particular. It will have various properties. It will going to have width, that is 100. We have defining them as a variable so that we can access them further on. We going to define the height will be like that, and its y component will be like height minus 30. We have just assigned a variable some properties. These are the properties of paddle variable. Now we can access these properties in the further on when we are going to use. If we have a doubt what is height here, every time the height is the canvas height. We have some global variable width and height which always give us height and width of the canvas respectively. So now we need to move on, and also there can be some doubt like why we have taken it as like not taken a hard coded, because canvas height can be changed. If anyone has changed that, then there will be uncertainty in our particularly code in sketch. So we need to avoid that. So we need to use the dynamic things here. Now we have initialized the paddle variable. Now we need to create the paddle, and we need to move the paddle. So we are going to do that part. So how we are going to do? let's move on to that particular part. As we know, the draw function is drawing everything in the canvas. So what we can do, we need to draw the pedal with its property. So let's set up the things. We are going to use the pedal, its X position, in its horizontal position. What will be its horizontal position? It will be like mouse. Mouse X will show our mouse horizontal position, and that is pedal dot width by 2. Why we have done that part? We are going to have a doubt. We always want that we control the middle, means center of the pedal. So we have used that particular strategy to do so. It will give the center of the pedal. As we know that pedal will be going to be a rectangle, so we need to create the rectangle rect. We have pedal dot x. What is going to provide x here? Its x position, and pedal dot y, it is going to provide its y position. Mean we have defined the coordinate where the pedal is going to be present. Now we need to define the coordinates for its height and width. This is width. We can see something there. Now we have defined the height, pedal dot height, where it will be going to present. Like we have taken here 15. We should use 30. Like it will be a good thing. Yes, we can see. And here we can do so 40, so that usually things will be good to see. Now we can see that from the like lower end of the canvas, it is 10 up, and now we also think here we can see that it is going into the canvas that we doesn't want. So here we can use two things. We can use if else conditionals, and rather than if else we can use constraint. So we are going to use here constraint because it is on the x1. So we are going to use here constraint, and the syntax for the constraint will be like in the constraint what we have three variables. We need to define the value, then its minimum value, and what can be the maximum value. So we need to define for the pedal dot x what can be its minimum, what can be its maximum values. So we are going to apply that part here. Constraint, like this is a function like that we can think of. Its initial value is this. Then that can be minimum, that can be 0, and maximum can be pedal dot w. So what it is going to do? Just give me a second to check where we have done the mistake. So basically, we have done a small spelling mistake. We have like not written s due to that it is not showing the. So now we can see it is not going inward. That is the thing we are going. We have tried to focus. Here it is going. Like what we can do. I guess that can work fine. Still, the maximum it can goes width minus pedal dot width. So by doing it 1.5, it is like here also working. Now our next thing is we need to have the ball which we are going to move. So we need to define the variables for the ball. So let's define the things for the ball. Let going to have ball again, like it will we going to use ball. We have created the ball. Then we are going to provide it some properties. What are the properties of ball? We are going to have some. its component like radius, height, and all. So we are going to have its property width. X component will be like we want always it start from the middle. So for that we are going to give that width. Y width by no, it should be height by 2. Okay, that done. Now we need to define the radius that we are going to use for it. I guess we should use semicolon here for the best practice. Here too we need to have semicolon. Now we need to have the ball structure. So ball we are going to have it in the ellipse form. That will be our best to use here. So we are going to use the ellipse. Now we are going to define the properties of ellipse. We are going to have the ball dot x as its position and ball dot y for its position. Then ball dot r star 2 that will be its position. Like here we can see the ball appear in the middle, and that seems small ball. So we want to increase its radius. That we can try 10 will be a good idea. No, we can do 12. Ah, it will be a good idea to use 12. Now we have some things like we have set up the ball. Now we need to add the moment for the ball, how it is going to move. So for that we need to introduce some velocities for the ball so that it will do things. Now we need to define some properties for the ball, that is its velocity and its x velocity and y velocity, so that we can use the collision effects. Now we are going to add the velocity thing. So we going to have some two properties for the ball again. So let's do that part. Ball dot dx, it's uh, like we can say horizontal velocity, and ball dot dy will be its vertical one. We are going to use minus. Initially we want that it will come downward, so that then we need to like how we should increase decrease these things. We need to think of that particular part. So how positioning will going to be changed, that ball dot x will going to be equals to ball dot, we are going to add up now. So for that, and now we can see it is moving. Now same for the x-axis, y-axis. Okay, it is going, it is going. Now you can see, but we need to have the collisions. Now we created that move ball will move. How it is going to move? We are going to add up every time the distance in it. We can see. Now what we need to have ball collisions. So how we are going to do that part? We should think and increment decrement that as per the requirements. So first of all, we are introducing collision. How we are going to collide? We know for the collision, we always know the concept. These are the boundary by which it will be going to collide. So if ball dot x component is smaller than ball dot r and ball dot x component is greater than width minus ball dot r, these are the constraints which we have applied, then we are going to have that ball dot dx star will be equals to -1, that we have make its velocity reverse in the x-axis and it is going to strike the x1. Now for the y component also we need to do the same. like for the y component. We can define, just give me a second. This is the syntax we are going to use. Here we have some conditionals that bold dot its y property should be smaller than bold dot r. Then if this happens, we need to reverse only the y direction. Bold dot by, we need to multiply it with -1. That's needed. It should work. Uh, so here we need to add for the button which we have all added the same one. Whenever the height is like height minus ball dot r y component, then it should reverse the direction. Now we can see that ball is totally colliding with the all the like walls. Now what is our next motive? We want that it will when it will strike to the paddle. That is our next motive. It is not doing that. So we need to implement the collision part for paddle. So how we are going to do? So let's do that part. Now we are going to have a critical conditionals. Like what we need to have when ball y component plus ball r component is always greater than y component. It's paddle y component in their height vector, and also whenever the ball x component and is greater than paddle x component, and next conditional and the last condition we need to use that whenever ball's x component is smaller than paddle, that is paddle x component plus paddle width, then we need to have a push the ball. So by performing the function we are come up with whole, like we need to implement that. Let's part by part implement it. Ball dot r is greater than paddle dot y. Let's have that only that part. So what we are going to do, ball dot dy, we are going to only reflect the direction y component 1 to -1. So we are going to think of that part and see one by one how that particular conditional works. Paddle dot y minus ball dot r. So here it is again that it is working. Here it is colliding. Now it will come, it will collide. There is like you can see it is colliding from that only surface. Now we need to implement that thing. Like it is colliding from this only, not from the paddle thing. So we need to have other conditions so that it will work as expected. So we need to add all x component should be greater than paddle x component, and you come up with like that part we need to see that same thing is going to happen. Now the next thing, last condition that is most critical among all, how that is going to help. That ball dot x component should be smaller than paddle dot x component plus paddle dot width. That we have taken the paddle and its height according to that. It will be like that. This is paddle and its component whenever it is in the range, then it will strike. If it is not in the range, then it will not strike. Now that thing is happening. I mean, we have done with our collision with this paddle part. Now, what is our next motive? We need to make the bricks so that we can perform the things. Now, let's create the bricks. We need to create the bricks. We will create the bricks in the setup function. And here let's assume uh, we need to assume some variables and need to initialize some of them. Let's start by doing that particular part. So for the bricks, we need to use the array. Like there can be more than one brick, na? So for that we need to use the array. So let's initialize the bricks array. Bricks is an array, that is an empty array. Now we also need to have number of rows and number of column we are going to have. Number of rows will be 5 and let number of columns equals is the variable which we are going to use. Let's assume it 8. These are the columns. And let assume some variables brick w and brick h that will represent the height and width of the brick respectively. Now we need to initialize the brick. So we need to initialize the brick width and brick height. So what can be the width of the brick? We want all to be the so that it can fix in the canvas. That should be number of column divided by the width. And what should be the brick height? That we can decide. That is our choice. We are going to choose it like 25. We have used here dynamic thing because number of columns can be changed and also number of rows too. Now we need to generate the bricks. We need to use the for loop here. So for let some r is here which is going to start from 0 and r is smaller than rows and r plus plus. So we need to have another column for the for let c is 0. These are variables which we have been using. C should be smaller than number of columns and that should be C plus plus. Oh, now we are in the right path now. We need to push, we need to put them in the array with their properties. So X property will be its position, which will be like brick width. Y will be brick height. R star, there should be C now. RH plus 40. So for now, we need to set up the width for the bricks that we have set up. That brick global width minus 5 and for the height we are going to use the same. Just height h minus 5 and we use property that is broken, that is like a boolean variable we are going to use. We are not going to use it now but later on we are going to use that. As broken is the property of the brick, so we are going to make it initially it should be false because it is not broken, so we are going to initialize it as false. Now we have provided all the properties for the brick, like it should be I guess was that way, yes. So now we need to show it. So for showing it we need to have it in the draw function. So we can use it here, bricks. Here we are going to use the for loop so that we can print the things. Bricks if we are going to use the conditional that if brick is broken then how we are going to render it. So it should not be broken. Brick should not be broken. P dot broken. It should be a property. Yes. Now, if it is not broken, then should have the rectangular shape. We are going to access that particular properties of the brick, b dot y component, p dot width, and b dot height. These are the properties which we are going to use, and we need to use the semicolon. Just db dot y. Okay, there is just dot y. So here we can see these all are the number of the bricks. Now we need to implement the broking logic so that whenever it hit, collides and break. So we need to implement that particular part now. we need to think of the two parts. We want that whenever it will touch on the horizontal axis, I mean on the edge, then it should go beyond and we are going to lose the game. And also we want that we always need to count the score. So that is the win-win condition we want now. So for that, we need to implement the core logic. Now we have implemented the brick breaking logic and like how we have created the bricks and how they are colliding. All these things are implemented. Now we need to implement the score logic. We need to have a global variable that represents the score. This is the global variable which we are going to use for the score. We also know whenever collision happen, this is the condition where collision happens. So we need to increase the score. Score plus equals to 1. We can do so. Every time the score is going to be increased. Now we need to display all the scores. So we need to have particular thing where we are going to show the scores. So let's fill it with like it is creating the white color text. Text size will be given as um, we can think of 16. Let's try 16. And then text will be like your scores. Hmm, score. What will be score? We are going to add score and its position 1020 where we are going to display. It is showing none for now. We are going to implement the things now. We are going to increase the score. Like I guess from here we should move it to bottom or after the in score increasing thing. I guess that can work. No, it is not working. Let's do the part. Other part, then we will do the scoring increasing part. We need to count the always need to count the remaining one. So we always need to have the remaining blocks. Instead of tracking breaks manually, we can derive game competition from the breaking state also. So we need to implement that particular thing in the here. So we can use let remaining is equals to 0. We have initialized that initially as 0. Now we are going to make it some logic or let b of bricks if b dot broken is a property. We always need to remember that broken, this is the property. We are going to increase remaining plus plus. So let's try if it is showing remaining or not. Here is the text. Okay, it is score is increasing remaining plus plus every time b dot broken. It is increasing in that way. So things can be done like we need to always increase the score. We need to initialize the score as 0 initially. I guess then it will be yes. It is going to increase now. That is why it is not showing. Now we need to implement the logic for the bottom touch loss condition. Whenever it will happen, but we'll be going to do like we need to think of the bottom touch. So we can implement it anywhere. Let's implement here bottom touch condition. How it is going to work if ball dot y component minus ball dot r is greater than height, then we need to think that it should end the game. We need to store the game state before that. It is going to give us error because we have not initialized it. Close. Okay, now game state should be a global variable. Let game state is equals to empty. empty string we have given. Now we need to implement the condition. As for now, if remaining that we have implemented the remaining logic. If remaining is 0, or we can say whenever the score is going to be equals to number of bricks column into mean it is going to be 30, then we are going to win. So we will going to implement that logic, so that code is getting messy. So here we are going to implement the logic. So when logic for the ending of the game, how we are going to do that? So we need if not remaining, we are going to use score triple equals to like number of the calls star row. We should think seems to be good, but it got paused. I guess we have not placed it in the right place. We can implement top logic, right logic, move. Okay, let's implement here. If score double equal triple equals to, that is a conditional. If score triple equals to columns dot call star rows, it is rows. So it is showing variable rows. I guess yes, it is that error. So what we need to do, we need to state game state is equals to win. Now at this time we are going to win. So now we need to introduce the generic system. Game state is always going to state us something. So we have a function, like we can implement the function. How? Here what we are going to do, we are going to ask win or lose condition we are going to display. If game state not equals to play, I mean if they are not playing, game state had changed, then what we are going to do, text size we can use 32, and at the end we are going to show that, so text a line can be done as center, it should be capital center. And what will be the text we are going to use it, that we are going to use here ternary operator to do so. If it is equals to win, we are going to ask that particular question, is we are going to win, then it will show you, or else it will be going to show us game over. And now we need to give the position of this text, width by 2 and height by 2, then we are going to give it proper center position. Then text size for the reset should be 16. So text size will be 16, and we are going to refresh the things. This is a function which we are going to implement again and again. Text click to refresh. That also we are going to display in between width and height by 2 plus 30. We are going to return here. It is showing refresh thing, but it is not working as we need to think in the function, and also we need to have the bottom condition properly working. Let's do that part. So we have, like, I have cleaned all of the code and all the logics are correct. Let's re-take the things which we have cleaned. Here, always game state will be going to be play, and here are the main logic. Here bricks we have implemented that earlier too. Scoring we are going to count, that is the paddle thing, and that refresh thing we have just added on. Then paddle collision condition, then win condition. Whenever we are going to lose or whenever we are going to win, that particular conditions are given here. So ball, whenever it will strike the ball, then it should be game state loss. When it is going to lose, then this particular conditional, uh, like we are going to lose, we are going to break the game. So we are losing here. That particular things we have implemented here. You can see the stop logic. Then again it is going to play. It is not equals to play. So not equal to play. It is going to check for the win. It is not win. So game will show game over and refresh the start. That's way how we have implemented whole of the game. Like we can see uh, now here, that is the logic, and it is game over. Now we again start here. We can do so. So here the game which we have decided, we have built that particular one. Thank you for all of your time to see the whole of the working and all of the things, code part and all. If any doubts, then please ask that particular doubt. If anything not clear, then give reviews and how we can improve the things. Please review that also part also.